Good morning, namaskar and welcome to the course once again. In the last lecture, we learnt how to prepare tender summary for a particular case project. We learnt how to identify those key objects which influences my bid price. In this lecture, we are going to pursue further the tendering process and we will learn how to carry out rate analysis. We would like to see how to carry out the rate analysis for direct cost items. We will also like to see how to carry out rate analysis for indirect cost items. Subsequently, we will learn how to apply markup and then we will see how to prepare the total bid price. So, we straight away move to the problem. Now, there are three ways in which we can carry out the rate analysis. The first one we call it as unit rate estimating and the second one we call it as operational estimating. In some cases, we may have to combine these two methods and we call this as combined operational estimating and unit rate estimating. We will try to take few examples for each of these methods and we will illustrate you how to carry out the rate analysis. Now, as far as unit rate analysis is concerned, we will apply this method in order to illustrate the costing of cement. Let us say the cement is OPC 43 grade and we would like to find out the unit cost of this particular material. Now, if you remember in previous lecture, I told you that when you calculate the cost of material, you have to consider the basic rate, you have to consider the transportation cost, you have to consider some other costs such as that cost you incur in intercarting and handling. You also have to incorporate wastages if there are any and thereby you try to get the total cost. So, here I am trying to find the cost of cement 43 grade. The basic rate of this particular material X cement factory price, which is inclusive of all taxes, I collected the quotation and I find that it is 5,700 rupees per metric ton. So, this is the cost I have written here. Then depending on the site location from the store, you can add the transportation cost. Here for this particular site, I have added 1000 rupees per metric ton as transportation cost for this particular material. Then I am further assuming that at the site, I will be roughly doing about 4 handling altogether. So, when the material comes to the store, I will be unloading it. Then when the material goes to a particular site location, there it will get unloaded. So, in total, I am assuming that I will do 4 handling and each handling let us say is costing me rupees 2 per bag. So, that way I have calculated it to be 160 rupees per metric ton, because in 1 metric ton you have about 20 bags, 4 handling 2 rupees per bag. So, 20 into 4 into 2, that brings me 160 rupees per metric ton. So, if you add all three you will get 6,860 rupees. Now, in cement it is usual to have a wastage of about 2.5%. So, that cost also needs to be included. So, I have calculated the wastage 2.5% on 6,860. Now, sometimes you sell the empty cement bags also. Let us say the cost of selling that empty bags is coming to be rupees 2 per bag. So, I am deducting this cost from the total cost. So, 20 bags in 1 ton of cement, and if you are getting a credit of 2 rupees per bag, I am getting a credit of 40 rupees. So, this cost is getting subtracted from my total cost. So, the total cost per metric ton is coming out to be 6,991. Now, each bag is consisting of 50 kg cement. So, per kg cement you can calculate it by dividing it by 1000, or if you want to do it in per bag which is 50 kg, you divide it by 20. So, you get 349.57, which is roughly about 350 rupees per bag. So, this is how you calculate the cost of OPC 43 grade cement. I will give you few more illustration. Let us say I try to calculate the cost of steel reinforcement. So, here I find the basic rate of material as let us say 35,750. Let us say this cost is inclusive of transportation cost also, that means this cost I am incurring at site. So, this is also sometimes called as landed cost. Now, at site I am incurring certain cost on intercarting and handling, let us say it is coming to be about 300 rupees per metric ton. Wastage in steel roughly it would be about 3%. So, I am getting 1072.50. So, total I add it up. If I am selling my scrap, then that credit I should have got for this particular costing, but right now I am assuming no credit. So, 0 here. So, if you add all these values, you are getting 37,122.50. So, this is how using unit rate method we are able to calculate the cost of steel reinforcement. Let us try to do one more example, that of calculating the cost of fine sand. Here let us say I am finding that the basic cost at site is coming to be 760 rupees per cubic meter. So, this is from the quotation that I have collected from different suppliers of fine sand. Sometimes you add the cost for screening, but right now I am assuming that I am not incurring any cost on screening. Wastage roughly it would be about 8%. So, you can find this cost is coming to be 60.80. So, if you add all of them together, you are getting 820.80. Remember, these are all direct cost only. Right now, I am not at all bothered about finding the indirect cost, but you know the total cost is the sum of direct cost plus indirect cost. Right now, we are concerned only about the direct cost. Now, I will explain you another method of analysis which we are calling it as operational, but before that we will show you the illustration of computing the labor cost. So, let us say we try to understand this with the help of one small example again. I am trying to find the cost of 1 cubic meter of excavation of earth in normal soil. Now, depth of excavation is varying from 0 to 0.5 meter. And in the second case, I will try to find out the cost of 1 cubic meter in a trench excavation. So, trench what you find, the width would be correspondingly lesser compared to the open excavation. So, here this is how a trench would look like, but if you see the open excavation, this could be a large area. Obviously, the rate for trench excavation is going to be more in terms of cubic meter compared to open excavation. Now, how do I do all such kind of analysis? I have from my past experience productivity rate for each of these items. So, for example, I know that if I have to do open excavation, I will be incurring about, let us say my productivity would be 2.16 man hours per cubic meter. So, if I want to do 1 cubic meter of excavation, my labor involvement would be roughly about 2.16 man hours. Now, I have already calculated the cost of 1 man hour for my organization. It is coming to be 109 per hour. I will show you how it has come. So, I simply multiply this estimated productivity norm with the per hour rate or hourly rate, and I am getting it like this. So, I multiply 2.16 with 109 and I am getting 235.44 rupees per cubic meter. Now, if I have to do the trench excavation, my past experience shows the value is going to be higher. So, that means I need more man hours for doing 1 cubic meter of excavation if I am excavating a pit, whereas I would require only 2.16 man hour if I need to do open excavation. So, here what I have done, I have taken 3 man hours as the productivity norm, and here again I am taking 109 rupees as hourly wages in the form of a direct cost. So, this when you multiply 3 with 109, you are getting 327. Now, what happens in a trench? The client is going to pay you based on the actual width and length. So, this is length, this is width, but you will find that at site you will not be able to maintain exact width like this in a vertical cut. So, what you will do? You might be doing this in some kind of a slope, but client is not going to give you payment for this extra excavation that you are doing. So, this is the extra excavation you are doing because you can't have vertical cut in a given soil. So, you would like to have some extra work done in the form of a slope. So, you will have to load the extra cost that you are incurring in maintaining this slope also in your rate. So, in general you can consider about 15% of your total cost for maintaining the slope and working space, but the client is going to pay you only for this area. So, we have to load for the extra work that we are doing on our per cubic meter rate. So, I am taking 15% on this value. So, this is coming to be 49.05. Sometimes if you are going deeper, you may have to carry out dewatering also and soaring also. So, you want to remove the water, you want to make sure that your slope does not collapse. So, in order to maintain that, you have to perform dewatering operation also. Now, there are specialized agencies who can give you the rate that you would encounter for dewatering, but for small jobs you can take it as 1% of the cost of labor. So, in this example I have just taken 1% of the total cost of labor. So, 1% of 327 I have loaded it in my per cubic meter cost. So, when I add all of them I am getting 379.32. I have rounded it off to 380 rupees per cubic meter. So, if you remember, for open excavation we are getting the rate as about 235 based on this assumed productivity norm, and for trench excavation I am considering a productivity of 3 man hours and I am getting a rate of 380 per cubic meter. Now, I will show you how did I get this 109. In all our calculation, you remember I use this 109 as hourly wage. For doing this, normally we calculate the weighted average of various labors and the cost that I am incurring on that. So, if you consider the Delhi rates, daily wages for a skilled worker is currently about 673, for a semi skilled worker it is about 610, and for unskilled worker the basic rate is about 536. Now, for calculating the hourly rates, what I do is I consider that for every one skilled worker I have 2 semi skilled worker and I have 4 unskilled worker. So, this is normally the combination of a particular gang. For every skilled worker you have about 2 semi skilled worker and about 4 unskilled worker. Now, what I can do is in the basic rates I will add some value to take care of my tools, tackles and minor consumables, because these workers are not bringing their own tools and tackles. So, as a contractor you will have to provide it, and roughly it would be costing about 7.5% of their wages. So, you take the 7.5% of this 673, so it is coming to be 50.48. Likewise, 7.5% of 610 you are getting 45.75, 7.5% of this 536 you are getting this. Overtime, for analysis purpose normally we consider 25%. If some worker is working in overtime, you will have to give double the basic wages that they are supposed to be getting during normal times. So, I am considering 25% extra on this. When you add it up, you get these values 972.49, 881.45 and 774.52. Overhead and profit, depending on your organization policy, it could be either 12.5% or 15%, you can add it, and then that way you will be able to get these values. Now, as I told you, you have to consider the weighted average. So, for this you multiply this value with 1, you multiply this value with 2, you multiply this value with 4 and divide the sum by 7. If you do this, you will find you are getting a weighted average of 868 for 8 hours working. So, hourly working you divide it by 8 and you are getting 108.54. So, roughly we are assuming it to be 109 rupees per hour. So, this is what we used in our previous calculations when we considered the cost of 1 cubic meter of open excavation and 1 cubic meter in trench excavation. Now, I will illustrate you some other method. So far you have studied how to carry out the unit rate analysis. Now, we will see how to carry out the operational estimation process. Now, in operational estimation process, all the time we have to consider the time frame. What is the duration and what is the quantity in which it has to be performed. So, in order to reflect these two aspects, I have given you a small problem. I am told that I have to estimate the rate of carrying out 100,000 cubic meter of M20 grade concrete, and it is to be completed in 16 months time. Total project duration is 20 months. So, although the total project duration is 20 months, but my schedule shows that the concreting operation has to be carried out only in 16 months time, and the total quantity involved is 100,000 cubic meter. So, if I have to estimate this, I have to separately find out the material cost. Now, you know how to calculate the material cost. I have to separately find out the labor cost, that also you know. Plant and equipment cost, I will tell you how to find it out, and overhead cost. In today's lecture, we are not going to discuss this part. In some other lecture, I will tell you how to calculate the overhead cost. Normally, these overhead costs are calculated separately and they are distributed either on a pro rata basis or front loading. If you remember, in previous lecture, I had told you about the concept of front loading and the concept of back loading. So, depending on the situation that you think is favorable to you, you can choose either the uniform loading or front loading or back loading. But as I told you, we are not going to discuss this issue in this particular lecture. So, let us start working on this particular example. So, first I try to estimate what is the concrete per hour production needed. So, let us say total duration is 20 months, it is given, but concrete duration is 16 months. That means, I have to complete all my concreting, which is equal to 100,000 cubic meter in 16 months time. So, for analysis purpose, I will assume it on a uniform basis. So, I will calculate the concreting that is expected to be done on a daily basis. So, it would be 100,000 divided by 16 months, and we are assuming that every month has 26 days. So, that means 4 non-working days. So, on Sundays we are assuming that we are not working. So, out of 34 Sundays gone, so we are left with 26 days. So, that gives me 240.38 cubic meter. That means, I am expected to do on an average 240.38 cubic meter. But construction is not practiced in following manner. Today you come, you pour 240 cubic meter and go home. Tomorrow you come, do again 240 cubic meter and go home. It is never done like this. So, you will find someday you will be doing less, someday you will be doing more, someday even more, and so on. So, you will find this is how your distribution of daily concreting operation would be like. So, in order to make sure that your equipment is capable of giving you even this production, which is the peak production, I am multiplying it with the value called peak factor. In this case, I am assuming it to be 1.5 times. Now, depending on your experience, you can multiply it with 1.25, 1.3 or 1.4. So, I am going to mobilize my plant and equipment, which can give me a productivity of 360 cubic meter per day. So, in terms of hourly production rate, I can divide it by 10. So, that means, I need a concrete production unit which can give me 45 cubic meter in an hourly basis. So, this calculation is done essentially to find out what kind of equipment is needed for my project. So, now I will look for that particular equipment which can give me 45 cubic meter hourly. Now, here again you have to make a choice whether you will go for a single equipment which can give you, let us say, 45 or 50 cubic meter, or whether you would like to go for 2 equipment of, let us say, 25, 25 or maybe even 20 and 30. So, it depends. Now, both of them have got advantages, both of them have got disadvantages. So, you have to take a call and then decide appropriately whether you would like to go for one equipment of this much capacity or 2 or 3 equipment of slightly lower capacity. Now, once you have decided the equipment that I am going to have a batching plant, I am going to have so many concrete transit mixer, I am going to have so many pumps, then we are ready to calculate the cost. So, here what I have done, I have taken 2 batching plants of 30 cubic meter capacity, because in case one batching plant fails, I can carry on the work with the other batching plant. Accordingly, I have taken 2 wheel loaders. Transit mixers, the number will be decided based on the lead, type of element and mode of placing, whether you are placing it through pump or manually. That will tell you how many transit mixers are needed. Mixer machines, I am keeping as a emergency measure. Suppose sometimes my machine goes under breakdown, I can carry on the concreting with these mixer machines. Tough riders, very handy equipment. I am proposing to keep 3 numbers. High lift pump 10 HP, I am assuming 3 numbers. Curing pump 4 numbers. Concrete pump, I am assuming with boom placer 1 number. Weigh batchers corresponding to each of these 5 mixer machine, I have taken 1, so 5 numbers. Vibrators, these are all small items, 15 numbers I have assumed. Builder's washed 5 numbers, and I am also assuming 3 tower cranes. Of course, the only 40% cost will be apportioned to the concreting items. So, these are the ways in which you calculate what type of equipment you need and how many numbers you need. Now comes the costing part. So, the first component of cost is plant and equipment owning cost. How much exactly you need in order to own these plants. Now, some companies, they have their own plants, some of them they take it on hire. Now, irrespective of whether you own it or lease it or hire it, you have to understand what is the hire charges on a monthly basis that you will be incurring. So, I am taking these hire charges, which are, let us say, the market values of the rental for each of these equipment. So, batching plant, I have 2 numbers, hire charges per month is 3,19,000. These values you can cross check, and maybe if you want you can change them. Now, this will be required for 17 months. Why 17? Although you know that concreting operation is going to last only for 16 months, but 1 month I have kept for, let us say, mobilization, demobilization. I am keeping some extra cushion. You can keep it 18 also, I am not going to debate that, but the idea is you have to have sufficient cushion so that in case you are supposed to be staying longer, you do not make losses. Likewise, for wheel loader, 2 numbers, hire charges, transit mixer, mixer machine, concrete pump, builder's washed, high lift pump, tower cranes, only 40% of the cost I am booking in concreting operation. Remaining 60%, it could be either in form work or it could be in reinforcement. If you put all loads, all the cost of tower crane here, your cost of concreting is looking very odd. It will look very odd. So, it is better to put it this way. So, I go on doing this, I calculate it, this value I am getting. Normally about 20% extra I keep it towards spares and maintenance costs. So, 20% of this I have added it here. Now, batching plant, tower crane, they require foundation, and for that also you need costs. So, I have estimated this cost separately. Assembling and dismantling also involves cost. So, that also has been taken care of. Mobilization of each of these equipment also requires lot of money. So, I have added that. So, I add all of them and I get this value as the total for plant and machinery owning cost. So, this is the cost implication if I am going to own these many equipment. Now comes how much cost I have to incur towards their fuel and power. Some of them they will run on electricity, some of them they will run on diesel. Accordingly, I have taken the cost. So, batching plant 2 numbers, but here you can see I have considered them only for 16 months, because irrespective of the time you will be keeping these equipment at site, only 16 months would be the running time. So, that is why I have kept only 16 for all of them, you can see, and every month 26 days working, 8 hours working every day, and batching plant, let us say it is supposed to consume 64 units of power at a cost of 6 rupees per unit. Then you also have to add the cost of oil and lubricant. Depending on the condition of equipment, this factor could be varying from 1 to 1.3. Older the equipment, you have higher values of this. So, you go on multiplying all of them and you get these values and you add it up total, and that is how you get this total operating fuel and power. Then comes operating labor. So, each of these equipment would require involvement of workers. So, for example, batching plant I am assuming 4 workers for 16 months, 26 days, wages 610. These are the kind of workers, kind of let us say semi skilled that we are getting. Transit mixer we have 10 workers for 16 months, 26 days, 610. Likewise for mixer machine, vibrators, builder's wash, pumps, concrete pump, tower crane, tough riders. So, wherever there are involvement of workers, you will write the number, you will write the number of months they will be staying there and number of days, and you multiply it with their wages. So, that way you get. Now, you can also add overtime wages about 50% here, and you add it up, you have this value as the plant and equipment operating labor. Now comes concrete placing labor. So far those laborers were involved with running of those equipment. Now here are the workers who will be responsible for placing the concrete. So I have assumed 15 number masons, 15 finishing masons, 10 carpenters, 10 fitters, 5 mates and 30 unskilled workers. So you can calculate the cost in the same manner. They are there for 16 months, 26 days in a month. The wages are varying. For unskilled it is 536, for semi skilled it is 610. Here also I am adding overtime charges of 50%. So this gives me total for my placing labor. Now labor cost for curing, that labor cost was involved in concreting operation. Now we need to employ some workers for curing of concrete also. So for this you need pump operator, you need helpers, you need further operators, helpers, coolies. Sometimes if you are calling them on Sunday, you have to give them overtime wages. In our case I have not assumed Sunday wages. So here also they are required for 16 months. In this case we are assuming 30 days, because curing you have to perform all 30 days, right, and depending on the wages you will get these amount. If you have to add admixture, that cost also can be added up. I have added 30 rupees per cubic meter for admixture. So this is how it is done. So what I will do now, this is the cost of owning, operating of my equipment, right. So plant and machinery owning cost, you already know how, from where it has come. Fuel power cost, from where it has come is known to you. Operating labor, placing labor, curing labor, and miscellaneous I am putting it for the admixture part. I can add it up total, and this I am dividing it by 100,000. What is 100,000? Remember 100,000 cubic meter concrete is the total scope that we have to done in 16 months. So that gives me 1851 rupees per cubic meter as far as the plant and machinery cost itself is concerned, right. Now we will see the material cost. So how much cost we would require in order to produce 1 cubic meter of M20 grade concrete. Although exact quantity you will be able to get only after the mix design, but for tendering purpose I can assume that I require 6.5 bags cement at a cost of 350 rupees. From where this has come, you already know this. So this is 2275. Sand, roughly it would require 0.6 cubic meter at a rate of 1200 rupees per cubic meter. This is 720. Aggregate, I require 0.9 cubic meter at a rate of 1300 rupees per cubic meter. So total is 1170. So if you add, I am getting 4165. Now if you look at material cost calculation, this is what? This is unit rate estimation method. Nowhere I consider the time, nowhere I consider the quantity. But when it came to this computation of plant and equipment, this is what is known as operational method, operational estimation method. Why? Because you needed to know how much is the total quantity, you needed to know what is the total duration. So all these calculations are true for 16 months concrete duration and 100,000 cubic meter concrete quantity. So that way you have been able to get this. If these values are changed, you might land up in some other value of plant and equipment charges. So, while you are working on operational method of estimation, you require to know the quantity and the duration, but when it comes to unit rate method of estimation, you do not need to know the quantity or the duration. Now, sometimes as you can see in this particular example, I used both. So, I combined both of them. So, you can see from A we are getting this plant and equipment cost. From the previous sheet I am getting this 4165, which is the material cost. Miscellaneous labor for pouring I am just keeping, this is from my past experience, 25. I add all of them and I am getting rupees 6041. So, for plant and equipment I used operational method. For evaluating material cost I use unit rate method, and I added, rather I combined these two methods to get this particular rate. Now, remember again, this is without my overheads. So far I have not done any discussion on my overhead part. It will be done in some other lecture, but to just make you more clear about this method again, I have given you one small problem again. So, you can see here in this particular problem, I want to calculate the cost of 1 cubic meter of excavation using plant and machineries. So, I have to carry out 40,000 cubic meter of earthwork in 4 months time. So, here again I am going to use operational estimating method, because I am given the quantity, I am given the duration. So, how do I calculate this? So, 40,000 cubic meter to be done in 4 months time. So, divided by 4. Even if you assume, let us say 25 days in a month, working days, it will be like this. So, how many cubic meter on a daily basis we have to do? It would be roughly about 400 cubic meter. If you are working for 8 hours, so divided by 8, so that means it will be about 50 cubic meter an hour. So, I am looking for a rate of 50 cubic meter per hour excavation, and I know from my past experience and from my knowledge that this much productivity can be given to me by a poke line CK90. So, I require one number for this, and I would require it to keep it with me for 5 months. Here again, although the actual duration is 4 months, I will take 1 month extra. Just in case some problem happens, I will be making use of this for that additional month also. Now, depending on the lead time, depending on the distance of disposal of earth, I will calculate how many dumpers or tippers would be needed. In this example, I have assumed it to be 3. This also is needed for 5 months, 1 month extra. Now, in the same manner, I am going to calculate the equipment owning cost. So, poke line, one number, hire charge per month for 5 months, this value. 3 dumpers, hire charge per month, 5 months, this number. Spares and maintenance, I am keeping 25% extra on this, so I get this value. Mobilization of poke line, whatever cost you can forecast, I have assumed 50,000. 3 dumpers to be mobilized at a rate of 20,000 per number, that also I have added. So, this is my total owning cost. Now, I will calculate the operating fuel cost. So, poke line, one number, 4 months. The actual running time is only 4 months, although I kept the provision of 1 month extra as far as owning cost was concerned. 26 days, 10 hours working, I am assuming 13 liter on an hourly basis. Cost of diesel is 70 rupees. Oil and lubricant, I am keeping 30% extra, so this is there. Tippers, 3 numbers, 4 months, 26 days, 10 hours, 5 liter per hour, 70 rupees per liter, 1.3%. I mean 1.3 is the multiplication factor to take care of oil and lubricant, this value. So, total is this. This is the cost for operating fuel. Then comes operating labor. Here also for each poke line I have kept one number, operator, 4 months, 26 days, 673. These are highly skilled workers, so I have taken the skilled workers rate. This is there. 2 numbers for bucket cleaning, 4 months, 26 days, 536. These are unskilled workers. Dumper drivers come under semi-skilled, so this is the value. Here also I can consider 50% overtime, so I add this and this, I am getting this value. So, how do I calculate the total cost for keeping this plant and equipment? This will be the sum of owning cost, fuel and power cost, operating labor. I add it up and this I divide it by 40,000 because my scope of earthwork was 40,000 to be done in 4 months time. So, I find that I am getting this value as rupees 124 per cubic meter. This value may change depending on your higher charges of different equipment and the consideration of petrol, diesel and other lubricants. If your equipment are new, you can find that this even goes down further. So, what we have done in this class is I have given you a glimpse of computing the direct cost, and this has been explained with the help of few examples. I told you how to carry out the rate analysis using unit rate estimation method. I also told you how to carry out rate analysis using operational estimation method. In one of the examples which I presented today, I also told you how to club these two values. So, we stop at this particular point. Next class when we meet, I will tell you how to carry out the rate analysis as far as indirect cost items are concerned. We will see what are the items coming under indirect cost, for example, the temporary structures, conveyance, salaries, labor benefits and many more things, and we will see how exactly we calculate the cost corresponding to each one of them. And in subsequent lectures, we will see how to decide the markup. Once you have the direct cost information, the indirect cost information and the markup information, you will be able to compute the bid price. So, more on this we will see in the next class. So, till then, thank you and goodbye.